In this video, we'll learn about ions and isotopes. Previously, we looked at the structure of an atom, which involved having our nucleus with our positive charge where the protons and neutrons are, and then having our electron cloud where the electrons are. Now, whenever we have a neutral atom, neutral atoms have the same number of protons as electrons. So our number of protons equals our number of electrons. But sometimes our number of electrons are different. When the number of electrons are different, that's when we start to form what we call ions. Our main group elements tend to gain or lose electrons to obtain the same number of electrons as the nearest noble gas. And so one way we can tell whether it's going to gain or lose an electron is to think about the type of atom it is. If it's a metal, our metals tend to lose electrons. So our metals tend to form cations. So this side here would most likely be our metals. And then our nonmetals tend to gain electrons. So our nonmetals tend to form anions. And so one thing to keep in mind when we talk about ions, the number of protons stay the same. So the number of protons stay the same, the number of neutrons stay the same. Oops, neutrons stay the same. It's only the electrons change. So whenever we have ions, you can remember our number of electrons changes. Everything else about the atom stays exactly the same, but the number of electrons will be what changes. And so if we look a little closer at forming cations and anions. First, let's look at cations. Cations are when we tend to lose electrons. So that means we have more protons than electrons. So the number of protons is greater than the number of electrons. And so for example, if I have lithium, lithium is 1 electron away from becoming helium because lithium has 3 electrons. So if lithium loses 1 electron, it now has 2 electrons in the atom, and then it got rid of 1 electron. So if it has 2 electrons, it has the same number of electrons as helium, the nearest noble gas. And so when we want to figure out how to write the charge and how to figure out the charge of our ion, we have to indicate the charge. So we know how many electrons we lost, or we know how many electrons we gained. So in this case, we lost 1 electron. So our number of protons is still 3 because lithium has 3 protons, but now there's only 2 electrons in it. So 3 minus 2 gives us a +1. And we can figure out the ion charge for any ion this way. Just look at the number of protons and subtract out the number of electrons. Every metal we have on the periodic table tends to form cations in this exact same way. Now let's look at our nonmetals. Our nonmetals tend to form anions. So what that means is the number of protons is less than the number of electrons. So an example is if we have fluorine. If fluorine gains 1 electron, it'll have the same number of electrons as neon. So fluorine we know has 9 electrons in it. If it adds 1, that means now fluorine will have 10 electrons total, which is the same number of electrons that neon has. And so we can figure out the charge the exact same way. So it'd be the number of protons. Fluorine, since it's element 9, has 9 protons. If I add 1 electron to it, now I have 10 electrons around it. So that means the ion charge is actually going to be a -1. And look, we wrote a -1 right there. So all of our nonmetals can form anions in this exact same way. You can do it with oxygen. If oxygen gains 2 electrons, it has the same number as neon. So oxygen's charge would be a -2. If nitrogen gains 3 electrons, it has the same number of electrons as neon. So nitrogen would have a -3. So the charge we write next to the anion tells us how many extra electrons we added to it. Just like how with the cation, we indicated how many electrons we took away from it. So not too bad. Remember, when you're looking at ions, you're only looking at the change of electrons. How many electrons changed? Everything else about the atom stays the same, but the electrons are what changes. Now that we've learned about ions, let's look at isotopes. Isotopes are atoms of the same element, but have different number of neutrons. So isotopes will change their number of neutrons. Isotopes change. So they keep the number of protons the same, so we know it's the same element, but the number of neutrons are going to change. So that means isotopes will have the same atomic number, but a different mass number. So they'll have a different weight to the atom. So for example of a few different isotopes is if we look at hydrogen. Hydrogen comes as 3 different isotopes. It comes as hydrogen 1, where it's just 1 proton and 1 electron. Then there's hydrogen 2, which is known as deuterium. Deuterium comes with 1 proton, 1 electron, and 1 neutron. And then our third type of hydrogen, tritium, comes as 1 proton, 1 electron, and now we have 2 neutrons. So you can see with each of these isotopes, the number of protons are staying the same, 1 proton in each of them. The number of electrons are staying the same, 1 electron in each. It's only the number of neutrons that are changing. It goes from 0 electrons for our first isotope. It goes from 0 neutrons for our first isotope to 1 neutron in our second one to 2 neutrons in our third one. And now let's look at how we would write all these different symbols for isotopes and how we can distinguish these different isotopes from each other. So whenever we write an isotopic symbol, what we're going to do is we always write the atomic symbol. So this is the 1 to 2 letters we find on the periodic table. That's really the symbol, the shorthand for our element. This way we know which element we're talking about. Then the bottom one here, Z, that's where we write the atomic number. That's the number found in the corner of the periodic table, or usually around the top of it. Remember, the atomic number tells you the number of protons in the nucleus. So our atomic number gives us our number of protons. And then finally, we have the mass number. This is the mass of the element in protons and neutrons. So this is where we add the number of protons plus the number of neutrons. And the reason we call it a mass number is it's looking at the atomic mass of that particular isotope. And in this case, when we talk about atomic mass, we're talking about it in atomic mass units. And if you remember your atomic mass units, protons and neutrons equal about 1 atomic mass unit each. So if we were to write our isotope symbols for our different hydrogens that we saw in the previous slide, we'd write H for the hydrogen. That's our atomic symbol. Our atomic number of hydrogen is 1. And then we'd write the mass number. Remember, the first isotope had 1 proton and 0 neutrons. So we'd write a 1 in the top corner. Pretty easy, right? So if we look at the next one, we had hydrogen. It still has 1 proton, So our atomic number is still 1, but now the second isotope, deuterium, had 1 proton plus 1 neutron. So that would give us 2 in the top corner. And then finally, if we look at our third one, you can see we have 1 proton, so we still have a 1. And you probably guessed by now, in the top corner, since we have one proton and 2 neutrons, would be a 3. Not too bad, right? Let's look at a second way to write our isotope symbols, where we just write the element and the mass number. We don't need to repeat writing what the atomic number is, because if we know the chemical symbol, we should know what the atomic number is right away. Or you should be able to look up the atomic number really quick if you know what the chemical symbol is. So it's a little redundant to write both the chemical symbol and the atomic number. So if we look at chlorine this time, for example, chlorine has the atomic symbol of Cl, and it consists of 2 different isotopes. Chlorine 35, where it has an atomic mass of 35, and then also chlorine 37, where it has a mass number of 37. So we can write our isotopes of chlorine in this particular fashion, or if you really wanted to, we can also write it as we saw in the previous slide. Chlorine is element 17, so we'd write a 17 in the bottom corner, and since its mass number is 35, I'd write a 35 on top. And then so I can do the same thing for the bottom one. I have chlorine 17, and then I have 37 on top. So what this means is for the chlorine, our number of protons equals 17. Since it's a neutral atom, our number of electrons are going to equal the number of protons, so that's 17. And now the number of neutrons is going to equal 18. And we can do the same thing for the bottom. So we have number of protons, still 17. Number of electrons, still 17. And now my number of neutrons, it's going to be that 37 minus 17, which will give me 20 neutrons. And so now you should be able to figure out what different ions are. Remember, ions are where we change the electrons. We're going to change our number of electrons in the atom. And then our isotopes are where we change the number of neutrons. And our protons always stay the same. So important thing, the number of protons always stays the same unless you're changing which atom you're talking about, which element you're talking about. And then looking at isotopes, you should be able to figure out the number of protons and neutrons in a particular isotope if you're given the symbol.